So question 9 is two particles are moving perpendicular to each other with de Broglie wavelength lambda 1 and lambda 2. If they collide and stick, then the de Broglie wavelength of the system after collision is. Okay. So question is very simple. Okay. So let us understand it well first before going to the solution. Okay. So here we have two particles. Okay, and they are moving perpendicular to each other. Yes. Okay, let me draw for like one particle is moving like this and another particle is moving like this. Okay, so they are perpendicular to each other. Okay, so let's take this particle A and it's assume it is B. Okay, so wavelength de Broglie wavelength of particle A is lambda 1. Okay, and de Broglie wavelength of particle B is lambda 2. So now it is saying that if they collide and stick, okay, so A is moving like this and B is moving in this direction. So at this point they will collide, and if they collide and stick, so then the de Broglie wavelength of a system after collision. Okay, so we are asked this wavelength of the system after the collision of both particles. Okay. So this was the question. Now let's move on to the solution. Okay. So we conserve momentum at the point of collision. Okay. So we are using equation Pi plus Pj is equals to P. Okay. So it is Pi and Pj because it is given in the question that both particles are moving perpendicular to each other. So one like this I, and for this J. Okay, so we are conserving momentum here and is equals to total momentum. Okay, so we know we have formula lambda is equals to h upon p. Okay, so p is momentum, lambda is de Broglie wavelength, and h here is we have the constant. Okay, so using this formula p is equals to h upon lambda. Okay, so we have used this here. So for first particle it is lambda 1, for second it is lambda 2. So h upon lambda 1 I cap represents direction, j cap also depicts the direction, particle 2 momentum is h upon lambda 2, and here h upon lambda, lambda is the total de Broglie wavelength of the system after collision. Okay, so here h and will cancel out and we will left with 1 upon lambda. Okay, so here we have I cap and j cap also. Okay, so to remove them, we have to take the under root. So we will get this under root 1 upon lambda 1 plus lambda 2. Okay. So after taking LCM, we will get lambda is equals to lambda 1 into lambda 2 divided by under root lambda 1 square plus lambda 2. This is the answer. That is option A is the correct answer.